Hello everyone. Today we shall discuss how to measure current through a circuit. For that we need a multimeter and few electrical elements like you see we have LEDs. See, these are LEDs. These are LEDs. These are diodes. These are resistances. You see. These are resistances. You see, these are also various types of resistances. Some connecting wires. This is a motor with fan, and we will show you how to measure current. The most important part to measure current is that you have to put the multimeter or ammeter connected in series. You cannot measure current in parallel connection, right? That is most important. Now for that, what you take, let us take a LED first and I will show you how to connect in series. Here you see there is a cell. We have a cell here. Okay, this is a cell. Two cells, and these cells are connected in series. That is 1.5 volt, 1.5 volt. It is 3 volt, right? And we will show you by measuring also that the cells are of 1.5 volt, right? And here you see this is the positive terminal, the red one, and the black one is the negative terminal. How to measure current through an LED? Let us find out first, right? Let us take one LED. For example, this LED we have taken, this one, right? First, here you see there are two terminals, one is bigger one and another one is small. The bigger one is positive and the smaller one is negative. Now you first put this positive with the positive terminal, right? You see, right? Now how to connect it in series, right? And here you see, you have to put the negative terminal with this negative terminal of the multimeter with this LED and the positive terminal with the negative terminal of the battery. Here you see, you have to put the knob in the current section. Here you see, this is current section, right? That is, it is in series connection. Again you see, the positive terminal of the battery is connected with the positive terminal of the LED and the multimeter is connected in series with this LED. How? Here you see, the negative terminal of the multimeter is connected with the LED. Here you see, this is our LED, right? And the positive terminal of the LED is connected with the negative terminal of the battery, that is connected in a series. Here you see. Let's see how much current it is. Let us put it at 20 milliampere. And you see the current passes through this LED is 6.55 milliampere, right? That is 6.51 milliampere. or 6.50. It is fluctuating, but it is nearly same, that is 6.46 milliampere. You see, right? Now the LED is glowing, and the current through this LED we are finding is 6.42 milliampere, right? It is fluctuating, nearly same, 6.42 milliampere. Now if we change this LED and take up another LED, let us check what is the current through it. You see, there is a bigger terminal, that is the positive terminal, and the smaller one is the negative terminal. You put the bigger terminal with the red terminal, and this one is small black terminal with the negative terminal of the LED, and let us see how much it is current passes through this LED. You have to put the red positive terminal with the negative terminal of the battery, check. You have to put this one, right? Now the LED is glowing. Now you can find how much current it is. You find the current here, you see here, here you see it is glowing, and the current through it is 6.29 milliampere. Here you see the current through this LED is 6.28 milliampere. 6.28 milliampere. In this way, you have to remember that whenever we want to check the current, you have to put the ammeter or the multimeter in series connection. Otherwise, you will not able to read the reading, right? You have to put the ammeter or multimeter in a series connection in the circuit, right? Here you see it is 6.25 or 26 milliampere. Now let us take another LED. Let us take another LED. We are taking another LED and checking current through this LED, right? Here you see we have taken another LED, and let us check. Now touch the negative terminal of the battery with the positive terminal of the multimeter. Let us check. Here also see this is 6.23 milliampere. 6.23 milliampere. That is 6.23 milliampere is current is going through this LED, right? Here you see 6.22 milliampere current is passing through the LED, right? Now if we take another LED, let us see how much current is passing through this LED. Let us take another LED. See here we have taken an LED like this one. The bigger one is the positive, and the smaller one is the negative terminal of the LED. Let us now you have to remember that you have to put the multimeter or ammeter in a series connection to measure current. It is not glowing. Let us see. Yes, it is okay. Now you see that whenever you want to measure the current, you have to put the ammeter in a series connection and you can measure the current through it. Now if I take this motor, right, and if we want to measure the current through this motor, let us find whether we can measure it or not. Here you see, we will connect this motor with the negative terminal of the multimeter, and we want to measure the current through this motor. Let us find what is the, let us connect it, connect the let us connect the motor with the negative terminal of the multimeter. Right, here you see, we are connecting this negative terminal of the multimeter with a fan, right, and we are checking current through this here you see, we are taking we have shown you how to measure current through an LED, right? And through these LEDs we have shown you. Now we'll check another thing, that is we can check whether an product or element is correct or not, that is by continuity, right? Here you see, now I will show you how to check this continuity. Here you see, there is the two sign, one is continuity and this diode. You can check diode here also, right? Now here you see, we put the knob in the continuity test and check whether a wire is in perfect condition or not. Let us check this wire. We have taken a wire and let us check whether it is in perfect condition or not, right? Here let us put the one end of the wire on positive side, on the positive terminal of the multimeter, and another, the black one, on the negative, on the other terminal. Let us check whether this wire is in perfect condition or not, that there is no cut in the wire. Here you see, this is a buzzer sound. Here you see, there is a buzzer sound, that means this wire is perfect, right? There is buzzer sound. Here you see, that means this wire is in perfect condition, right? Right, that means we can check whether an wire is in perfect condition or not. That means this wire is perfect, right? You can check the LEDs also, whether it is in perfect condition or not. You can check the LEDs also with the help of multimeter in the continuity section. Suppose this one, this LED is correct or not. Let us check. No, this LED is not working. That means this is a bad one. It is not working, right? This LED is not correct. Let us take another LED. Let us take another LED. You put the positive with the positive and negative terminal with negative terminal. Let us check whether it is in perfect condition or not. Yes, it is glowing. Here you see, that means it is in perfect condition, right? Let us take another LED. Here you have taken another LED. This is the positive connection and this is the negative, and let us check. Yes, it is glowing. That means this LED is also okay. You can check in the buzzer section or continuity test, right? Let us take this motor also. You can check the motor also whether it is in perfect condition or not. You see there is a buzzer sound, right? That means this motor is also in perfect condition, right? Take another LED, this one, and put it in positive and put this one with the negative of the terminal. You see it is glowing. That means this LED is in perfect condition. You can check whether it is in perfect condition or not. Now you can check also the buzzer also. Here you see we have taken a buzzer, right? And if we take in the current section, you will see that the buzzer is having a response or giving a sound. Right? In this way you can find other factors also. Let us take a diode, right, and check whether the diode is in perfect condition or not. Here you have taken a diode, and we know that diode has a unidirectional current. Only in one direction it can pass through, right? Let us check whether the diode is in perfect condition or not. Here is checking that there is a reading on the multimeter. That means this diode is correct. If you change the direction of this diode and let us check, there is no reading. That means this diode is in perfect condition, because diodes the current is flowing through is unidirectional. That is, in this direction it is right? It is giving a reading 539. That means this diode is in okay condition, right? Let us take another diode, this one. We have taken another diode, this diode. And let us check whether it is correct or not, right? Here we are checking the diode. No. Here you see there is no reading. That means in this direction there is no current. If we change this direction, let us check. Yes, there is a showing reading. That means this diode is in okay condition, because diodes are unidirectional. Only in one direction current flow through a diode, right? This diode is also okay, right? Right? Now, here you see we have some resistances also. You see these are resistances. Now I will show you how to measure resistances. For resistances you have to put this knob on the resistance. You see here we have put this in resistance like 200 ohm. The range is 200 ohm, 2020k to 200k and 2000k, right? Let us check. Right? Let us check. It is 200 ohm. Let us check the resistances. Right? We are taking in 2000 ohm, and let us check the resistance. Right? These are the resistance. Let us check what is the resistance here. Right? Here you see 900, it is 979 ohm, right? Here you see the reading is 979. Here you see again, let us see the reading also. Here you see we are checking these resistances, it is 979 ohm. That is nearly 1k, right? Let us check another resistance. This resistance we can check also. Let us check another resistance. Here we are checking these resistances. Here you see it is also 975 ohm, right? It is nearly 1k. This resistance you see, we are checking this resistance with the multimeter. Here see the resistance is 973 ohm, right? We are checking the resistances one by one. You see we are checking this resistance also. Let us check. Yes, it is 980 ohm. 980 ohm, that means nearly 1k, right? These resistances are of 1k. And if you want to measure the resistance of this one, let us check how much resistance it is. You have to put this in 200 ohm. Here you see we put the knob at 200 ohm, and let us check the resistance of these resistances. You see the red one. Let us check this red one. The resistance of this red one is 10.9 ohm. It is 10.9 ohm, right? Now it is, let us check this resistance, and this resistance should be measured in this way. It is 19.6 ohm, 19.6 ohm, right? It is 19.6 ohm. We want to check these resistances. This resistance is about 20.1 ohm, 20.1 ohm. And these resistances, let us check this one. This resistance is 28.3 ohm, 28.3 ohm. In this way you can check the various resistances, and you can check the LEDs, you can check other elements also, right? Now we will check the voltage, that is DC voltage, right? That is voltage of battery. Let us check the voltage with this help of this multimeter, right? Now what have we do? Let us check the volt of this battery, right? For that you have to check put the knob on the voltage section. Here you see this is the DC voltage section. This is the DC voltage section. Here you see this one is the DC voltage section, and we put it at 20 volt, and let us check the batteries. Here you see there is a battery here, and let us check. This is the positive and this is negative. Put it positive with positive and negative with negative, and check what is the voltage. The voltage is 1.55 volt. You see it is 1.55 volt. Let us take another cell, this one, and let us check how much it is. This is positive with positive and negative with negative. It is also 1.54 volt. If we change that polarity, that is plus with the minus and minus with the plus, then there will be a minus sign. Here you see that is minus 1.53, right? 1.53 volt, right? If we check positive is positive and negative, it will be plus, that is 1.53. If we change the polarity, here you see, then we are getting a minus sign, 1.48 volt. That is 1.48 volt with this battery. Now we have a cell here also. Here you see this is a cell hour, and these cells are connected in series. Let us check the voltage, and for voltage you have to put the multimeter or voltmeter in parallel connection, right? Now you see this is negative and this is the positive, this is positive and this is negative. You see here, see, and it is 2.92 volt, right? That means the battery should be connected in parallel to measure the voltage of these cells or batteries, right? Here you see we got the voltage, DC voltage 2.92 volt, and one other was is 1.45 or 1.55 volt, right? In this way you can check various things also. We have checked the LEDs also. Now we can check also the HAV section, that is with the transistor you can check. Now these are transistors, you see here. We have taken 2 transistors here, right? And let us check what is the beta value of these transistors, right? And you can find out the beta values of these transistors also. And how to check whether this is an NPN transistor or PNP transistors. For that it is very easy. You have to put the transistors in this slot. There are 2 slots. One is NPN, another is PNP. If you put the transistors in NPN slot and if it shows a reading, then it is an NPN transistor. And if you put the transistor in PNP transistors and it shows a reading, then it is a PNP transistors, right? Now let us check whether these transistors are PNP or NPN. For that, let us take any of the transistors here I have taken and put it in this slot, that is here you see emitter, base, collector. Let us put these transistors in any of this slot. Here we have put it. You see there is 0 sign, that means it is not giving any reading, and you have to change its terminal, that means emitter should be collector and collector should be emitter. Change this and again put it here, that is common base emitter. In this case also you see that there is no reading. See, that means this is not an NPN transistors. Now you put this in this here in the PNP section and let us check whether there is any reading or not. In PNP section let us check. You have to move these transistors again and again such that you may get the perfect value. There is a number also, you can see the number also on these transistors. Let us check these PNP transistors. You have to check again so that you are sure that these are PNP or NPN transistors. Let us check again. Here you have to put the knob in the HEV section and let us find the beta value of these transistors, right? You have changed it again. Let us check the beta value of these transistors. Here not showing any reading. Let us put in the NPN section. Can you see? We are getting a value 281, right? The beta value of this transistor is 281. You see, 281. That means this is a NPN transistor. Here you see, you have put it on NPN section, and this is, you see clearly that this is the emitter. Here you see, this is the emitter. This is the base and this is the collector, right? If we take out this transistor and take it right, and this is a flat portion, we have taken the flat portion, right? This is the flat portion, and this is 1, 2, 3. This is the flat portion. Here you see, and if we number the terminals, that is 1, 2, 3, then 1 is the emitter, the middle one is the base, and this is the collector, right? We got the beta value of this transistor, right? And it is an NPN transistors, right? Let us take another transistor, this transistor, and let us check whether it is NPN or PNP transistors, right? We put it in the PNP section and let us see whether we are getting a reading or not. You see, there is no reading, and change it, the emitter and the collector point, right? Let us change it. You see, we are getting a value 275, right? We are getting a value. That means this transistor is of PNP transistor. You see, this is, we have taken PNP transistors, the PNP transistors, right? And this is the emitter. You see, this is the emitter. This is the emitter. this is the base, this is the collector, right? And you can see this is 275 beta value of this transistor. And if you take these transistors in this way, that is 1 to 3, and if you measure, that is 1 2 3, it is the emitter, it is the base, and this is the collector, right? Now we have found that this is a PNP transistors, right? And if you check through Google, we also found the same thing, right? Now we have learned how to measure current, how to measure voltage, how to measure the HFE section of transistors or beta value of transistors, right? And we have checked the current also through any element, through LEDs or through any of the things. And also we check the continuity test, right? Continuity test we also check. And the last one is the square wave. Here you see, this is our square wave. Here you see, this is our square wave section. This is the square wave section. For square wave section, what if you do? You have to, for the square wave section, what you have to do? You have to, you need an oscilloscope to show this reading. We don't have now oscilloscope. Later on, we will show you how to measure the square wave with this multimeter. And the last, not the least, is the voltage section, AC voltage. Here you see, you can measure the AC voltage from 200 volt to 750 volt. But here you should be very cautious, because there is a probability of short circuit, or there is a probability of a risk to read this measure, right? You have to be very cautious about this. You have to put this knob at 750 volt. You see 750 volt, and check the AC current. Here for that, we have taken an AC adapter. Let us see, and let us measure the current, measure the voltage of AC. Let us check. For that, what have to do? But you have to be very cautious about it, whether your probes are right or correct or not. Otherwise, it will be very dangerous to measure this. Let us check this section. Here we are taking let us check. Here we are checking the AC voltage. You see, this one we are checking the AC voltage. Let us check the AC voltage, but you should be very careful about it. Otherwise, there may be a shock. Here you see, the AC voltage is 242 volt, 242 volt, right? 243, 243 volt. The AC voltage is 243 volt. Now we show you every part of this. We show you the AC voltage also, right? I will show you every part of this multimeter. What you can measure, let us repeat once again. With the help of this multimeter, you can measure the AC voltage. The range is from 200 to 750 volt. The DC voltage, the range is 200 millivolt to 1000 volt. The resistances, you can measure from 200 ohm to 20,000 K. You can measure the continuity test or the diode also. This is the square wave. This is the HFE section of transistors. And if you want to measure the current up to 10 ampere, you have to put this probe here. Only then you can measure. And this is the NPN and PNP section. And you can find out whether whether a transistor is NPN or PNP. If you put the transistors NPN, And if there is a reading, that means it is an NPN transistors. And if you put it on PNP and if it gives a reading, then it is a PNP transistors. And you can also find the emitter base collector from this slot also. You see there is given slot emitter base collector and emitter. Here is the emitter collector base or collector base emitter. Right? In this way you can find out the various reading on a multimeter. Right? In this way. And for probes, we already told you that there are two probes, the red part, right? This port should be connected here, and the black one, that is negative, it should be put it on the common, right? And you want to measure more than about 10 ampere, and you need to put this here, and you have to measure the current through any product or any element. You have to remember that whenever you want to measure the voltage, you have to put it in parallel connection, and whenever you want to measure current, you have to put it in series connection. Only then you can measure. Dear friends, if you like this video, please subscribe, like and share, and thank you everybody for watching this video. Hello friends, today we shall discuss about transistor. Here you see, these are transistors. It has 3 terminals. You see here, there are 3 terminals. And the shape is on one side, it is flat, and on the other side, it is semicircular. Right? You see, these are transistors with 3 terminals, and on the upper part there is flat on the one side and another side that is semicircular. You see, this is semicircular and this is the flat part. And there is a number here. There is a number given on this part. The number I am telling you, the number is, let us see. Here you see, number is I am telling you, the number is S8550D331, and another one is, there are 2 transistors, you see here, 2 transistors, and another one, you see, there are 2 transistors here, right? It has 3 terminals, and we don't know what type of transistors it is, right? We'll find what type of transistor it is with a multimeter. For that, here you see, we have taken a multimeter, and we'll find the HFE, that is the beta value of the transistor. Here you see, we have taken a transistor. We will find the beta value of these transistors. Let us find. Here you see, we have taken a transistor, we have taken a multimeter, and we will show you the various parts here. Here you see, this is our off position, this is our AC voltage, it ranges from 200 to 750 volt. It is our DC voltage, it ranges from 200 millivolt to 1000 volt. It is our resistance, it ranges from 200 ohm to 2000 K. It is a continuity test. This is our square wave, and this is the HFE. Here you see, there are 2 parts here. You see here, This is for the transistor part, right? You see there is a division in the middle, that it is the NPN section and this is the PNP section, right? In NPN section you see this is the emitter, this is collector, this is the base, and here it is also given as emitter, right? You have to put these terminals here, emitter, base, collector, or emitter, collector, base. Here in PNP transistors, you have to put these terminals here, emitter, collector, base, or emitter, right? In this way, you can find the value of HFE. The first question is, what is HFE? That we have to know. HFE, what is HFE? Now, know about HFE. Now, HFE means, here you see, we have written here, HFE. HFE is the hybrid parameter forward current gain common emitter. It is a measure of DC gain of a junction transistor. Right? HFE is the hybrid parameter forward current gain common emitter and is a measure of DC gain of a junction transistor. The common emitter DC gain based to collector current gain HFE is calculated by HFE is equal to IC by IB with VCE at constant voltage. HFE is also called the beta F, the forward DC current gain. It is often simply written as beta, right? This is HFE. That means you have to find the value of HFE or beta of these transistors. Now you see, we have shown you that we have taken two types of transistors. Here you see, in this transistor there are three terminals and one is number is given here, one number. We can show you later on the numbers, right? These numbers help us to Google or to pin out which pin is what, right? In this case, let us take the number first. Here you see, we have taken this multimeter, right? What you have to do, you have to put this, you have to first separate what kind of transistor it is. Actually, in transistor there are two types of transistors. One is PNP transistors, another one is NPN transistor, right? You have to find out which one is PNP and which one is NPN transistor. How to find? You can go to Google and type the number written on these transistors and write pin out. You will find which type of transistor it is. Let us take one transistors. We have taken the transistors and the number of this transistor is D331. The number of this transistor is S8550D331. It is a PNP transistor. How will you know that it is a PNP transistor? What if you do? First of all, take this multimeter, right, and put the arrow on HFE. Here you see, we are putting it on HFE. See here, we put the jack on HFE, right? Now take this transistor, right, and put it on the NPN junction, that is emitter collector base, right? Let us put it in this junction and see what is the reading. There are 3 pins and we are putting it here. You see, here you see, we put it here. It is emitter base collector, and the reading is 0, right? First you have to put in this way and turn this one, and again you put this here again, right? Here also you see that the reading is 0. That means it is not an NPN transistor. It is showing 0 value. That means it is not an NPN transistor, right? Let us put it in PNP, right? You have to put this transistor in two ways. One is collector base emitter in this way, here you see it in this way, and then turn this one and put it in this way, emitter base collector. In both the you see the reading is 0. That means it is not an NPN transistor. Now if we take this transistor and put it here, and put it on emitter base collector, and let us see what happens. Yes, you see, there is a value of 274, 275. That means it is a PNP transistor, right? Whenever it gives some value, that is that one. Here we have taken it on PNP transistor. Here you see PNP transistor. That means it is a PNP transistor, and it is giving a value of 275. You see, 275. That is the beta value or HFE of this transistor is 275, right? Here you see 275, and it is a PNP transistor. Now you have to find which one is emitter base collector. You see here you have taken. That means here you can see that here this is the emitter, this terminal is the emitter, this terminal is the base, and this terminal is the collector. And let us take out this one. See, this is our transistor, and it is a PNP transistors. Now let us find out the pin, right? Here you see there are 3 pins here. Here see, and take this flat part. This flat part is in this way, flat part. You see, flat part is in this way, right? Now you can see what we have found out, that this is, if we give a number, it is 1. This pin is 1, the middle is 2, and this is 3. The number 1 is the emitter, this is the base, and this is the collector, right? Because we found some value when we put it in PNP transistor. That means it is a PNP transistors, right? And the number of this transistor is S8550D331. It is a PNP transistors. Here you see the number is also, you can see the number also. Let us try to see this number. Anyway, we cannot see the number. Anyway, I am telling you that it is S8550D331. It is a PNP transistor and it is a beta value of 275. Right? Now you have taken another transistors. Right? Now put these transistors here. Let us take another transistors. It has also a number. The number is C8050D. Right? Now, to check whether it is an NPN or PNP transistors, you have to put this in the multimeter. First of all, we are putting it on PNP transistors, right? You put it on PNP. Here you see, on PNP it is giving value of 0. You see here, you put this here and the value is given 0, and again change it and put it in this way. Here also you see the reading or value is given as 0. That means this is not an PNP transistor, right? This is not an PNP transistor. Let us put it on the NPN transistor, right? NPN, right? Let us put it in the NPN transistors. Now here you see, we put it on NPN transistor. Let us find out whether there is, if we got any value or not. You see, we are getting a value of 280, right? We are getting a value of 280. That means it is an NPN transistors. 281. We are getting a value of 281. That means it is an NPN transistor. Here you see, it is NPN, right? And here you see how we got this pin. Pin is, you see, this is our emitter, this is the base, and this is the collector, right? We got a value of, let us see what is the value. We got a value of 200. If we got a value, that means that is the transistors. Here you see, we got 280, right? That means it is a NPN transistors, NPN. And the terminals are, if we take it as number 1, this is emitter, this is base, this is collector. Now I am taking out this transistor. Now you see here, this transistor. And if we put these transistors in this way means the flat portion on the flat portion here. And if we name it as 1, 2, 3, and this is the emitter, this is the base, and this is the collector. Now, I'll show you in Google whether it is true or not. We have got the transistors and they are PNP or NPN transistor or not, and we have taken out the correct pin or not, right? You see, this is number is C8050D. It is an NPN transistors and it is the repeat number is 1, 2, 3. This is the emitter. This is the base and this is the collector, right? That is on the flat portion. Here you see, we have taken it on the flat portion like this, flat one. And if we name it as 1, 2, 3, this is the emitter, this is the base, this is the collector, right? Now, we will find from Google whether we have got the right transistor or not. For that, you have to take it on the Google and find whether these are correct or not. Here you see, we have written here two numbers. The numbers are S8550D331, it is a PNP transistors, and there is another number that is K901C8050D, it is an NPN transistors. Let us find it from Google whether it is correct or not. Let us find it. If we win out this number, let us take. Let us find from Google what is the number. Here you see, number is S8550 transistors pin out. You see, the number 1 is the emitter, number 2 is the base, and 3 is the collector, and it is a S8550. S, you see here is S8550. D331, it is a PNP transistor. You see here, we found it from Google that it is S8550 transistor pin out. It is PNP, number 1 is emitter, number 2 is the base, number 3 is the collector, and this is the flat part. You see, this is the flat part, right? That is, number 1 is the emitter, number 2 is base, and 3 is the collector, and this is the PNP transistors. This is PNP transistors. Now let us take the other transistors pin out. Let us take and find out. We have taken another, we see, we have taken this one, C8050. It is an NPN silicon transistors. Here you see, you have taken the flat part, that is, 1 is the emitter, 2 is the base, and 3 is the collector, right? That means we have got the correct answer, right? It is C8050 NPN transistor, silicon transistors. Number 1 is emitter, number 2 is the base, and number 3 is the collector, right? In this way, you can find the HFE of various transistors, right? In this way, you can find the various HFE of various transistors, right? In this way, you can find the HFE of various transistors. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.